Welcome to Study Loop.
This is the answer to Chapter 21, problem number 83 from the Smith Organic Chemistry textbook. This problem gives us two sets of data and asks us to come up with a structure for each set of data. So the two data sets have a common molecular formula, which is C9H10O. And so we'll start by calculating an HDI for that formula. And so that is going to be 2 times the number of carbons, which is 9, plus 2, minus the number of hydrogens, which is 10. All of that is going to be over 2. So we have 18 plus 2 is 20, minus 10 is 10, divided by 2 is 5. So our HDI, or degrees of unsaturation, is 5. So each of these molecules is going to have an aromatic ring, because remember that accounts for 4. And so I'm going to say tentatively that each of these is an aromatic ring with a carbonyl. Okay, so looking at A, the IR peak at 1700, wave number tells us that there is a carbonyl in this molecule, and the peak at around 2700 wave number tells us that this is an aldehyde. Okay, so then moving on to the NMR data, we have a 1.2 ppm triplet with an integration of 3. And so this is a methyl group next to a CH2, which is why it's split to a triplet. Our next signal is a 2.7 ppm quartet with an integration of 2. So this is, So this is the methylene group that's next to that methyl group. So signals 1 and 2 are splitting each other here. And so we have a methyl group next to a methylene group. The signals at 7.3 ppm and 7.7 ppm, each a doublet, each with an integration of 2. So this tells me that we have a para disubstituted, so I'll say para disub aromatic ring. Okay, and our last signal, the 9.9 ppm singlet that integrates to 1, that is our aldehyde proton. Okay, so when we put this all together, we have an aromatic ring. We have a methylene group next to a methyl group, so like that. And then para substituted to that, we have an aldehyde. Okay, and so that's the structure of A. We'll do the same thing for B. So looking at B's IR, again, the peak at 1720 wave number tells us that there's a carbonyl here, and the peak at around 2700 wave number tells us that it's an aldehyde. So we have another aldehyde for B. So looking at the NMR, we have a 2.85 ppm triplet that integrates to 2. So this is a CH2 group, methylene. And then we have a 2.95 ppm triplet that also integrates to 2. And so this is another methylene group. And they're both triplets, so there's a pretty good chance that these are actually next to each other. They're splitting one another. 7.2 ppm multiplet with an integration of 5. So this is a mono-substituted aromatic ring. So mono-substituted aromatic ring. Again, we know that because the integration is 5. And then at 9.8 ppm, that singlet that integrates to 1 is our aldehyde. So we only have one substitution on this aromatic ring. We have 2 methylene groups and an aldehyde. So there's really only one way that we can put all of that information together. So one methylene group, a second methylene group, and then an aldehyde. Okay, and that is the structure of molecule B. All right, and so that's the answer to this problem. again, as always, when we're given a formula, start by calculating an HDI, and then look at the IR information that we have, and then look at the NMR information that we have. Try to figure out the pieces of the molecule based on the NMR signals and the splitting patterns, and then put everything together. And that's the answer to chapter 21, problem number 83.